Good morning. Welcome to the Central Newfoundland Morning Show for Friday. It is the 29th of January.
Yes,
wow.
Sorry.
I'm Leanne Power.
And I'm Melissa Tobin, and it's the last day that we'll be talking on the show for January.
Right. Okay.
Because when we come back on Monday, February. And coming up at 7:20, if you think that there's turbulence in the atmosphere now, just wait until climate change accelerates. So we'll speak with a scientist who says the bumpy skies will become more frequent. So you'll want to listen to that if you're a flyer.
Now, it's not going to happen for, it's going to be decades before we see a real big difference, but it's happening. It's changing already. Well, as you heard in the news this week, an American Airlines jet en route from Miami to Milan had to divert to St. John's because of turbulence. Several passengers and crew were injured when the flight met an extremely bumpy patch of air. Stories like that make the news because they're not all that common. They do happen, but not all the time. But new research says that's going to change if climate change continues unchecked. Dr. Paul Williams is a Royal Society University Research Fellow in the Department of Meteorology at the University of Reading in the UK, and I reached him at his office. Good morning, Dr. Williams.
Good morning.
What evidence is there that there is more turbulence in the air these days?
Well, a specific study that we've published has been looking at computer simulations, and what we've done is we've increased the amount of carbon dioxide in the atmosphere in those computer simulations. So we're not looking at actual atmospheric observations in our study. We've been looking at computer simulations of the future when we can crank up the carbon dioxide. And what we find is that the temperature patterns and the wind patterns in the high altitude atmosphere are very tightly coupled together. So if we change the temperature patterns, which is what we're doing with those CO2 emissions, the wind patterns are changing as a consequence. And what's happening specifically is that those high-altitude winds are getting stronger because of climate change. And that's increasing the probability of the instability that causes turbulence to occur. So what we're seeing is an increase in both the average strength and just the amount of turbulence in the atmosphere in those computer simulations.
You're looking into the future, but is there evidence that this is happening already?
I think it's too early to say right now, and in fact it's a bit difficult to predict exactly when a clear trend will emerge just from the normal variability. We've seen some quite high-profile turbulence encounters in recent weeks and months, and in fact that's quite normal. The amount of clear air turbulence in the atmosphere does peak in the winter months, so it's normal in December and January and even into February to see a spike in those turbulence statistics. So it'll be some time before we can make any attribution statements to climate change, in the same way that we can't say that a particular heat wave or an extreme precipitation event has been caused by climate change. We won't be able to say that a particular turbulence encounter has been caused by climate change. But what we can say is that climate change is making those things more likely to happen in the future. But quite when the signal will emerge from the noise is open to question. But in the coming decades, I think we'll see a clear signal emerging.
You mentioned clear air turbulence. What's that?
Yeah, there's different kinds of turbulence. Certainly flying through a cloud is always a turbulent environment, but that is normally experienced on the ascent and the descent phases of the flight. What I'm talking about here is what we experience at cruising levels above the clouds and the weather systems. And this is clear air turbulence, called clear air turbulence to distinguish it from the in-cloud turbulence. This is turbulence above the clouds in clear blue skies. It's invisible to the pilot. There's no electronics on board that can see this kind of turbulence coming. The radar doesn't pick it up because it's invisible to the radar. And that's why it's the kind of turbulence that leads to injuries, because typically the seatbelt sign will be switched off and passengers will be moving around the cabin.
We know that there's a lot of evidence now, and it's indisputable that our atmosphere is warming. So according to your simulations, that will be changing the way that turbulence affects airplanes. What's it going to mean for commercial flight when that begins to happen?
Well, there's a number of consequences. The obvious one is that flights are going to get bumpier. Flights are going to get less comfortable. We've been focusing on transatlantic flights, but there's reason to think that other flight routes around the world will also be susceptible to these turbulence increases. I have to stress that turbulence is very rare. It's normally an issue of comfort rather than safety. But there is an indication here that there'll be an increased risk of injuries to passengers and crew. Currently, we think something of the order of a few hundred passengers and crew are injured annually. So we're looking at an increase in those figures. Flights might need to be diverted around patches of turbulence that are particularly strong. That could increase journey times and cause delays at airports. So I certainly keep my seatbelt fastened whenever I fly now. I didn't used to, but the number of passengers who are injured who have their seatbelt fastened is really very low. It really is the best thing you can do when flying is to keep buckled up, even in the middle of the flight when the seatbelt sign is not on and you're not required to be buckled up.
Can turbulence put planes themselves at risk?
It has done very rarely. I know of a case where a small plane was flying through very strong clear air turbulence, and it was so strong that one of the engines broke off mid-flight. This almost never happens, and planes are built now to very exacting specifications, and they're built to withstand turbulence stronger than anything that's been experienced in the past few decades. So it's not a risk to the structure of the plane. It's just a risk. It's a comfort risk, and very occasionally it puts people in hospital who have not been buckled up when the turbulence has hit.
Well, that leads to the question about the severity of turbulence. When you looked at the models that you did, looking at the frequency of turbulence, can climate change or warming atmosphere conditions affect the severity of turbulence as well? Yeah, we found in these supercomputer simulations that the average strength of the turbulence was increasing by between 10 and 40%. And there's a range of uncertainty there. We looked at 21 different mathematical models of turbulence, if you like, 21 different ways of diagnosing the strength of that turbulence, just to account for the uncertainty that we have. Turbulence is it's notoriously difficult in science. It's very hard to understand and predict and model. But we were finding a robust increase in the strength of turbulence, somewhere in the range between 10 and 40%. We were also finding a very statistically significant increase in just the amount of airspace containing significant clear air turbulence. We think it's currently about 1% of airspace contains turbulence, and that's why it's a rare event. 99% of the atmosphere at flight levels is smooth, but it's that 1% that you can just hit randomly, and we're talking about a doubling of that 1% to become something like 2%. So more turbulence around in the coming decades because of climate change. Well, Dr. Williams, I want to thank you very much for explaining this. I appreciate your time.
It's a pleasure to talk to you, Leanne. Thanks very much.
That's Dr. Paul Williams, a Royal Society University Research Fellow in the Department of Meteorology at the University of Reading.